This conference will now be recorded.
Good morning, guys. So now we'll get into Azure Pipelines, which is crux of your Azure DevOps. Okay, where you compile your application and generate the artifacts, and then run the unit test cases for the code quality, and set up Sonar Cube for the code quality verification. Okay, uh, and then you set up some quality gates to fail your build or make your build successful, etc. There are many things in Azure pipelines, and in Azure pipelines, the compilation part is called as a pipeline, basically. uh, the overall, I mean, you will have two things. One is pipeline and release pipeline. When you say pipeline, it is just a CI. When you say release pipeline, it is a CD, basically continuous deployment, okay, or continuous delivery. We will talk about continuous deployment or delivery once we complete this pipeline part, where you build the application and do all the code quality checks, etc. Okay, before we get into that, let's see what we have, right? So as part of our end-to-end architecture, we have done with our planning phase, and then we have done with the coding phase. So in planning phase, we have used Azure Boards and learned all the requirements management and Scrum, etc. And then in version control, which is in coding phase, we learned Azure Repos with all the Git operations. Okay, so you have seen what a developer have to do, what a team have to do, and what's your responsibility as well. Now from here, continuous integration, Artifactory, and continuous deployment, it is fully your work actually. Okay, of course, they have the code developed. I mean, developers develop the code. Now you have to take it forward to build and deploy your applications to different environments for testing, and as well as VAT, and then for the production environment. So we're going to now learn all these things under continuous integration. So for continuous integration, we are going to use Azure pipelines. So what you do, you will build a package is nothing but your project or solution, and then you also measure the code coverage, and then you also do a code analysis. When I say you basically go, and as a DevOps engineer, you go and configure the tools to do all these things, basically. Okay, to do all these things, you need to fetch the code from the repos, because Azure Repos is the place where you're putting our code, basically. And then we will use Sonar Cube server for code quality. Okay, and we will generate code quality results, and analyze the results along with the results for a build and test as well. Okay, and this is a continuous activity. That's the reason you see arrow symbol like this. Okay, after that, it will go to the Artifactory. Artifactory, we have many external Artifactories as well. One famous is a JFrog and Sona Type Nexus. Those are two very famous Artifactory repositories. We talk about them. Okay, but here we will use Azure Artifactory to store our binaries, or you would say, when you say binaries, output of your compilation, right? So when you compile .NET, you will basically get DLLs and some configuration files. Okay, when you compile Java application, you will get jar files. I mean, these are the extensions, basically. So for better management of these binaries, we will keep them in an artifact repository. Okay, so we will talk about what is artifact repository and why we need it, etc. Once we complete continuous integration. Okay, so let's get into continuous integration part, what you do and what a developer will do, etc. Okay, so these are the below activities that we're going to do as part of the CI pipeline. For CI pipeline, as I said, we're going to use Azure pipelines. Okay, now you already seen branching and merging and versioning part, right, as part of the repos, and also you learned code merging, etc. For code merging, you have a number of ways, or a number of operations. You can use stash, you can use merge, you can use cherry pick, you can use pull request. All different ways you learned it. From there, You're going to configure automated builds, going to do a code analysis, unit testing, quality gates, code coverage, continuous integration, binary repository. There is a definition for continuous integration itself. Okay, binary repository, build metrics, application configuration, automated deployment. It comes after this. Okay, deployment metrics. Okay, so forget about this automated deployment and metrics. When you do all these things like automated builds, analysis, unit testing, coverage, quality gates, continuous integration, build metrics, and application configuration, binary repository. When you do all these things, then only you can say that I have implemented continuous integration in my DevOps pipeline. If you miss any one of these things, like to say, if you miss quality gate, if you miss coverage, etc., then that is not a true continuous integration. Many people, what they do, they simply configure automated builds and they say, hey, I implemented continuous integration. That is not true. Basically, the true definition includes your quality gates as well. Okay, quality gates is an umbrella, under that we do code coverage, etc., etc. Okay, but for the time being, you remember all these keywords. uh, you will learn all these things in the next in the next upcoming sessions. Okay, now how do you build a pipeline, right? So before I go and talk about pipelines in Azure DevOps, let's go and see what a developer do manually when they don't have a DevOps, right? And it is very important for you as well to learn or to know all the manual activities that a developer or a team basically do it for their compilation part actually, or for their build activity. Because the reason is that for any automation, as I said, the manual activities are important because you take each and every manual activity and convert them into automation. Okay, that is one part. The second part is that as a DevOps engineer, you have to do build and deployments or CI CD for many different languages. Okay, you may do it for Java, you may do it for .NET, you may do it for Python. Okay, whatever is the programming language, your steps are not going to change. The steps will remain the same, the concepts will remain the same. Okay, but the thing here is that you don't know each and every programming language, and also in most of the cases what happens, whoever is doing these DevOps operations, they are not the developers. They might have come from the infrastructure background, they might have come from the testing background. Okay, very less people move from development to DevOps. Okay, so what you have to do, since you don't know programming language, at least you need to know the basics of each and every programming language. And you need to ask the developer, hey, you are doing the build activity, tell me how you do it. Are there any manual activities that you do it other than other than from Visual Studio activities or the Eclipse activities? Like that, you need to start asking the questions. That's what I'm going to show you now. Okay, and then we'll get into automation. Okay, clear?
Yes,
Yes,
Pawan.
Purna.
Okay. Yeah. So this is where many people get confused. How do I know, etc., etc. Okay, but you need to ask the questions. Okay. Now let's go and see what a developer do it. So for a developer, CA is a simple thing because everything is included in his Visual Studio if he is a .NET developer. uh, Everything is included in Eclipse if he is a Java developer. Eclipse or IntelliJ, there are many tools. You might have remember when we were cloning the application, right? In the drop down, everything is populated in our Azure Repos. So those many IDs are there. Okay. Now, so for a developer, uh, building application means he will simply go open this solution, as you know, right? Uh, I'm not going to do any team explorer activities. Let me close this. So this is a solution. Solution name. Solution means It contains many number of projects, one or more basically. Okay. To develop any application, you need one or more projects. So this is a web project where you have all UI related, and you have the unit test cases for web as well. Okay. Unit test cases are very important. If you don't find unit test case projects in solution, then immediately ask your project manager or whoever is leading that, right? Ask them, hey, you don't have unit test cases. That means you cannot have the code quality gets configured in the sonar queue. That is the first thing you need to do. Without unit test cases, your code quality gate cannot be configured. Okay, because this is the base. Okay. So right now I have only one project, right? One for web, I mean web application, and another for unit test case. Let me add one couple of more projects as well as a developer. Okay, not a DevOps engineer.
Now one question.
Yeah.
So in unit test cases project, who will execute the
Mm-hmm.
test cases? Like who will
Yes.
define them? What need to be
Tell.
tested? What need to be verified?
I lost you, Kiran. Can you come again? In unit test case project?
Who will define on what need to be executed as part of
Okay.
test plan, something like that?
No, this is not part of, when you say unit test cases, this is not part of the test plan. Test plan comes from the test engineers. Okay. It can be manual test cases. It can be automated functional testing or automated security testing, etc. What developer do here is a uh, white box unit test cases. White box is nothing but coding basically. They write code. So they see in this project, if you go, they go and write a lot of code here, right?
Yes.
They go and write a lot of code here. So they need to validate themselves, right? Whether that code is working or not. Okay. One is they simply go and use their eyes and use their brain to do it. But that will not help me. That will not help the third person, right? For a third person, obviously he needs to provide some evidence, right? So for that, you need to have the unit test cases. So whatever they do manually, they will write it in this unit test cases projects. Okay, this is not part of the test plan. But only one thing is, if you are writing 100 lines of code in any one of, I'm just giving you some number. If you are writing 100 lines of code in bundle.config, all those 100 lines of code should be validated by some unit test case written in unit test case project. It will go and verify basically. So you will see that how it will verify. Okay. it's
So
not part of it's not part of test plan.
okay, it would be odd. It would be. I mean, unit test.
It,
Sorry, the test budget would be added, but it would be defined automatically by the code part.
yes, this is a developer activity. Okay. Developer need to ensure that he has a unit test cases to cover all the code that he written in other projects basically for the functionality.
Okay, so
Okay.
if the code is getting updated, then this project also need to get updated, or would it be automatically updated?
No, this is not automatic, this is manual, right? This is also coding activity. This is also
Okay,
code. Everything is a code. Whatever you see in a Visual Studio is a code actually. There is no automation here. They are writing some code here. Let us say you are writing some login functionality in home controller.cs. Okay. Generally, many project guys, what they do, they verify it. They run the application and they verify it whether that code is working or not. Okay. But that's a manual verification, right? How do I keep track of it? Imagine that the developer leaves the company, or he goes to some other project, or the functionalities keep on increasing. You have a 10,000 lines of code. Okay, who will remember? Nobody can go and test each and everything every time, right? At least they will miss something. Okay. That's the reason
okay,
unit test cases are important. It's a developer responsibility and then code reviewer responsibility. It's everybody's responsibility. Your project manager, architect, lead needs to ensure that the developers are writing these unit test cases. But this is a time consuming activity. Let us say you take some 10 hours to develop a login functionality. Obviously you take another 5 6 hours to write the unit test case as well.
okay.
You getting me? That's the reason people give less attention for these unit test cases, and that's why they spend a lot amount of time during the testing phase. because they come, I mean, they will run into many issues.
But as a DevOps engineer, how would this unit test cases project help you?
Yeah, that's what I'm saying. I mean, code quality gets, probably you missed it. Okay, so we have the concepts. Okay, when we are configuring this quality gate, okay, we need to ensure that they have the unit test cases. Okay, and if you don't find see, you don't, all you need is a project here. Okay, unit test case project. Okay, if you
Yes.
find the unit test case project, then you are good. Okay, because you really don't care whether unit test cases are present in this project or not. All you care is you need a project, because you need to configure it basically for the code quality gate. If there are
Okay.
if there are enough unit test cases, then their quality gate result will be good. If there are not enough test cases, then their quality gate result will be bad. Based on the results, their project manager or architect or lead, whoever is managing the project, they will go and take the action. Okay, for you it doesn't matter whether they write a good code or bad code. It doesn't matter. Your responsibility is configuring these things. Okay.
Okay.
Okay, so let me go on to one or two projects just for our demo purpose. So what these developers or lead, they do, they go and add uh, projects basically. Okay, go to the solution, add a project. It's not your work. Okay, I'll go and add one. Okay, ASP.NET web application, but here I will select, I will say uh, microservices. Okay, same repos. When you say create, it will ask me MVC or web API. I will say web API. This is for APIs. I don't configure HTTPS. This is fine. Add unit test case for this one as well. It's up to them. Okay. For our simplicity, I don't add it. Okay. Then say create, because at least I have one project, one unit test project. That is enough for me for the code quality. Okay. I just want to take multiple projects, means more than one project. Say multiple means it can be one, two, or 100. It doesn't matter. So let me close everything. Close all documents. Now I have this new project. You see plus symbol here, right? Okay. Now I need to push it to my remote repository. Okay. What I do, I'll keep it in the dev actually. Okay. uh, it's a new one, right? That's why it is still showing. Okay, let me add it. So see, when a project is added, right, your solution file will get modified. You see the tick symbol. The reason, your solution file knows only about your projects basically. Okay, how many projects are there, where, I mean, it's a metadata file. Your project file contains your file information. Okay. If you want to see it, all you need to do is go to this, explore it in a file explorer, and you see this your journey.sln, right? You can open in a notepad basically. Okay. I'll say, i'll I'll take it, I'll put it in here. Okay, let me update this commit. Okay, some changes are there in the remote repository. That's why the merging conflict is coming. Okay, that's okay. I will say pull. Okay, and then I'll say push. Oops. Oh, okay. Pushes to this branch are not permitted. You see, you must use pull request to update this branch because we protected the dev branch with the pull request. You can't do directly. You remember? We protected that. Let
Yeah,
me go
yes.
ahead. So, since we are now exploring this CI pipeline, let me go and remove those protections so that we can quickly do our work. Okay. Go to branches, dev, right? Now this is a protected. Go here and then branch policies. From here, remove these things. Okay, that's it. Now I should be able to pull it basically. Sorry, push it. Push. Okay, successfully pushed to origin slash dev. Origin means, as I told you, it's a remote. Okay, done. So I have more than one project. Now you want to explore, let's explore this one, this solution file, what you see. It's important basically. I mean, you always do this kind of things. Okay, open with, I'll say, I'll say, oh, notepad. See what this contains. Okay, it will contain, I mean, you see, is some versions. Okay, and then how many projects are there? You have project, your journeys web is one project. Okay, and it is giving the path and everything. Okay, you see, and some id. Okay, and then the second project, your journey web dot test, and third project, microservices. Okay, it contains that project name, project, how many projects are there, all those project information, and then there are some settings. Okay, uh, when you debug, there are two types of compilation. One is a I mean compilation with the debug mode, compilation with release mode. Guys, when I say compile or build, both are same. Those are synonyms. Okay, so you can compile with the debug mode or you can compile with release mode and any CPU. See, I think in future we can remove this any CPU option because in older days, the CPUs were very different and your application generally don't run on multiple CPU versions. But in the current days, everything is almost same. So it's always any CPU. Okay, and then you have some settings. Okay, you can see debug release. Okay, and everywhere it is debug or any CPU at the solution level. And then what you see, some these are something related to your project, I mean, which is used by your Visual Studio. All you need to carry is the project names. Okay, whatever you see in your solution file, those will be here basically. Okay, similarly you can explore your project in project file, right? Similarly it will contain all the file information, basically how many files are there, all those things are referred there basically. Okay, now for a developer, a compilation or build means he simply right click on the solution and he simply say build solution. That's it. Now if you see, you can see the verbose here. It is compiling. You see the build started for this your journey web, that is the first project in your solution, and then build started for the microservices project and debug or NACP. Where this debug or NACP you selected, you can see in the top here, debug release any CPU. That's it. Okay, this is how a developer simply build his application. Okay, or compile his application. Now everything is, you see, build, 3 projects succeeded, 0 projects failed, and 0 projects up to date, 0 skipped, etc. And what is the output of this compilation for your journeys web project? What is delivered? In the same path, your journeys web, I told you that there will be a bin folder, and that under that bin folder your journeys web.dll is generated. Similarly, for microservices project, microservices.dll is generated. Similarly, for your test project, your web test project, your journeys web.test.dll is generated. So the output of your compilation is a DLL. Means, so you learned, right, as part of your academics, machine understandable format, right? So whatever you write in Visual Studio or in Eclipse or any IDE is not understood by machine, right? When you compile it, all this English will be converted to machine understandable format, and that format is DLL basically for .NET application. All your code now, whatever you see, .cs files, not the scripts, etc. Whatever you see in the .cs files is converted to a DLL basically. All your code converted to DLL. Okay, where do you see that? You can go and explore it. So these are your projects under your repo. These are your project microservices, and there is some packages came up. Package is nothing but reusable component. So for your application to run, uh, your system, I mean, your Visual Studio already added many packages here. These are all the references. Under references is see of projects. These are all the project, actually these are all the projects developed by some other Microsoft developers or some other people. They developed all these things, and they made them as a reusable components here. Okay. And since our Visual Studio or Eclipse are very intelligent, when you add a new project, it knows what components to be added. Okay. Other than this, developer also will go and add their own reusable components here. Let us say sending email, they need some obviously each and every company email functionality is very common. Many developers our teams create some reusable components, and they create a DLL. So the developers, right, they go and add those DLLs here. They go and add reference, and they browse the DLLs on their laptop or wherever it is, and add it. So it will come and display here. Okay. And all these, some of them come up with, as part of the installation of your Visual Studio. Some of them will not. Whatever is not part of your Visual Studio installation or framework installation will be added separately using a tool called NuGet. Okay. So how do they add? Let us say something is not part of your the downloaded references here. You can say references are DLL reusable components. How do they add a new one? One is they can go and add this reference like this. I mean, whatever is there in their laptops or repos, etc. Okay. The other one is they can go and generate, I mean, download from a public repository. So public artifactory, I would say public artifactory. So you can go and say manage NuGet packages. NuGet is a public artifact repository where the developer community from the outside world or anyone, right, they can go and create a reusable components and upload to NuGet website. Okay, that NuGet website artifacts are being displayed here. For .NET, we use a NuGet package manager. You can see NuGet package manager. Other word is NuGet artifactory. Or, and this is a public artifact. This is not private. Anyone can go ahead and push their artifacts here. Now let us say I want to use some email related. I mean, as a developer. So as a developer, I'll go and search if there is any email related. You know, Sorry, I am searching in the installed. Click on the browse. See, there are many reusable components or DLLs developed by developer community. One very famous one that people use is a SendGrid. You see, this is a C sharp. It will give all the information. C sharp client library for using Twilio is IBM basically. IBM's product. Twilio SendGrid APIs to send mail and access web API 3 endpoints, etc. Once you once a developer install this, all this functionality will be available in their projects. Basically they go and simply install it. You see, click on install, that's it. This is a public artifact NuGet. So if somebody asks you, hey, what is artifact that .NET guys use it, you simply say it's a NuGet artifact where all the developer communities are uploading their reusable components for the use by others. Now it is trying to install it. So you need to know this. All the references, external references, can be downloaded from here. Okay, I think this is done, or still going on. You can come and check here as well. So it is getting added to microservices project. Yeah, here only. Okay, still going on. Let me see, it's completed. Solution Explorer. You should see a plus symbol, any one of here. No, nothing is been added. Rose, right?
It will be added separately. That's what you told, right? Not.
No, no. But you have to see it here, right? I'm
Okay.
installing here. You have to see it here.
Okay.
It When you download it, it is getting placed in some folder system, right? And that
Okay.
have to be. If it is not part of these references, how your Visual Studio knows that
Right.
there is a reusable component getting used by your project.
Okay.
It probably it is taking time. Okay. Now this install option is disabled. No, actually it is stuck. Actually, I'm not able to click. I'm clicking it here, right? It is stuck.
Maybe it is installing.
Now something is happening now. Yes. I think I need to format my system somehow. I think this is done somewhere. Now you see send grid is added here. This is a new one. Okay. And then I can see my project file is also edited now. You see project.edit. It is pending for edit. That means a new file has been added to microservices project. You can see from the bottom as well, 3 changes, right? Click on these 3 changes. See, when I add a new reference, how many files are updated? One web.config is updated, and then packages config .config is updated, and my project is also updated. My project contains the file information, the path, and everything. Packages.config includes the package information. So you have a file called here. This is important for you as well. You see packages.config, all the whatever you downloaded, you know or whatever is not available with the .NET installation and are downloaded from nuget.config are appearing here basically. If you open this, so all these packages are not available in your .NET installation. That's why your Visual Studio automatically downloaded, and the one developer manually added is this one, SendGrid. And with along with SendGrid, it looks like this is also added star bank ECDSA. So you don't know basically when you use a NuGet manager, right? It knows what dependencies to be downloaded as well. Okay. Now other one is web.config. Double click this. You can see the web.config. Now you can see the differences. Okay. What is being added here? SendGrid. So the web.config is the file where it contains all the references and along with your custom made entries as well, like some database names or user IDs, passwords, etc. So it made many changes here as well. Okay, it's difficult to do like this. I can go and search for it. Okay, but you don't need to worry. I mean, me means developer don't need to worry. Yeah, it will take care. It will be taken care by Visual Studio. Okay. What is this? I am just searching. Control F. Okay, what is this? Send. But it made some changes. That's what I see. Okay, forget about it because it is taken care of by Visual Studio. We don't need to worry about it, and you are not a developer as well. Okay, let me go ahead and then commit send grid added. Okay, just for demonstration. That's it. So that's how the developer will go and add it. Why you need to know these things? Because you're going to give attention for this web.config and your packages.config and your project files and solution files, and as well as the references in your CI pipeline, because this is a Visual Studio and it takes care of everything, all the building related activities or compilation related activities. But you are not going to compile as a DevOps engineer. You are not going to compile or build the solution from the Visual Studio. You are going to do it from Azure Pipelines or Jenkins or some other tool basically. Why you are going to do there? I mean, why people need to do there? Because whatever I see is in my Visual Studio and it is a manual activity, and I don't have tools to make it effective in terms of quality gate or code coverage, code analysis. And if I do it, it is on my own. It is not a it is not in a proper governance model, right? I can make or break anything. I can suppress any errors as well. I may not show my errors to the other people, etc. Right? All these are the issues. Okay, that's why you are putting in the Azure Repos for the better quality, sorry, code maintenance, and then you do it from the pipelines where everybody's code is in the server, right? We don't take the code from the Visual Studio. We take the code from the Repos, which is a remote repository that contains each and every team member's code, and we will do all this compilation and code coverage, etc., etc. From the Visual Studio also people can do the code coverage, etc. Okay, but the thing is that you can cheat the people as well, right? I would say you can say, hey, I don't have any errors. I mean, we can do all that stuff. How developers do their analysis? From the analyze button, they can go and do a run code analysis from the analyze button. You can see now it will build the application and it will analyze the code as well. So for each and every programming language there will be some best practices. All those best practices now will be validated by Visual Studio. So if you can see this, it your Visual Studio basically rebuild, means it again built the solution and done some code analysis inside. If you see, right, basically Visual Studio uses a component called MS Build to compile the application, because there should be some software which converts your human readable language into machine readable format, right? So that is I mean, that software is called MS Build. You call it as a build utility. In .NET you use a build utility called MS Build. In Java they use a build utility called Maven. Okay, so many people don't know even that there is a component called MS Build, because it is taken care by I mean Visual Studio. Okay, and it analyzed using some rules in the fxcop. The software name is fxcop cmd.exe, but the tool name is fxcop. Earlier, if you go back to 7-8 years ago, both were, I mean, Visual Studio was not having the built-in component of fxcop. From last 7-8 years it has been part of Visual Studio basically. Whoever started their career before 2010, they know how this used to happen. We have to install it separately and then integrate with Visual Studio. Now it is integrated with Visual Studio itself. Okay, so it done all the analysis basically. Okay, all these things we're going to do it on our Azure pipelines basically. See, they can suppress the issues as well. That's what I was telling, build and suppress active issues. You will get some issues here if the code is not perfect. Okay, and they can do unit test cases and everything they can do here. Okay, and you want to see all the properties of a project or the settings of a project or a solution file, you can simply right click on the solution, go and click on the properties. So it will show all your projects basically. Okay, and what is the configuration? Right now this is in the debug mode. Okay, I'll tell you what is debug mode. When you if we will use the debug mode for the compilation during the development activity, but uh, when we going to compile it for the deployment purpose, we have to use the release mode. Okay, I will show you. We have to use the release mode. Debug mode means see, when you click on F5 or run this application, it will open web application and show you all the content. For that to happen, your system need a lot of some additional metadata, that you call it as a debug information, but that is not required when you deploy it on the server, because you on the server you are not going to run the application using Visual Studio, right? Once you deploy it, the end users will access it from the browser. So the funda here is that in any program debug mode. Okay, remember that. And similar, if you go and look into the properties of micro project, any project, this pane will appear. So it will give you what is the assembly name. Assembly is nothing but your DLL. What is the name of your assembly? By default, you will get the project name. And what is the namespace? What is the framework? It is .NET Framework 4.7.2. Framework is nothing but your software. And what is the output type? Class library means your DLL. Okay, and then start a project, etc. Some you can set some icons as well. Here we don't mind it. And build, what happens? You have a debug mode and release mode. All they can simply change here basically. Okay, and it is making something, debug constraints. You don't need to worry about this. Is for Visual Studio. All you need to know is so this will be there. All the outputs will be going to bin. Okay, and for if it is a web project, when you run this application, the web project will run using this URL, localhost 65357. It automatically creates a port and do everything basically. Okay, when you run this application, basically if I run this, click on this, I'm just giving you a tour of how a project look like and what you need to do. See, when I run this application, it actually using URL called localhost and then 62170 port basically. This is being taken care of by your Visual Studio. Okay, but if you see here, you see a different port here, right? 65357. What it means, when Visual Studio run this application, right, that port is not available. That's the reason it automatically identified one more port and started running this application. Okay, okay, it is using IIS Express to run this application. Okay, this is part of CD, but I'm just showing. Okay, you see many other things. How do you publish web? How do you publish SQL if there is an SQL projects? Okay, build events. What we need to do before compilation and after compilation, that we call it as a pre-build event and post-build event. Okay, people can go and add some uh, any scripting information as well. It will go and run, actually your Visual Studio run that. Okay, before build and after build means when I click on build, before it build the solution, it will run this script here. Okay, once it completed the build, it will run the script whatever is here. Okay, you can see the command line. Okay, and then resources, nothing, settings, doesn't have any settings, reference pass, and then signing. Forget about, this is to protect your DLL. If you sign it, most of the people don't use it because it's all internal. Sign in means nobody can open and you know do some hampering to your DLL. Okay, don't worry about it. And then finally, this is what important: code analysis. See what how this Visual Studio is doing the code analysis. It is using a library called Microsoft.codeanalysis.fxcorp analyzers. So it is somewhere installed in your Visual Studio as part of the installation. Okay, and then suppress results, it is already tick marked. Run and build, if you select this on each and every build, it will run basically. Okay, and you see all the rules here. When you say rules, it will show all the rules what are part of this code analysis. There are some managed, you don't need to worry, I mean, but these are all the rules. There are many rules here. Okay, this is a rule id, rule description, and what is the level, is it a warning, is it a error, or is it information related. Okay, three types. You can see there are many you see under code analysis for C sharp, all the rules are selected. You see all the rules. So many things are done by Visual Studio for the developer basically. See. So all these rules, some of them are hidden, some of them are info related. Anything is red is a dangerous, they have to fix it actually. Okay, these many things are included in your Visual Studio project, similarly for your Java project as well. Okay, now you need to know what you need to inspect when you are creating a pipeline. Okay, these are all the things that you need to understand. Okay, now let's get back to any questions before I move on to other concept.
So all the settings, whatever you have shown, that will be done by developer, right?
No, this is not even done by developer, these are all done by Visual Studio. All that.
Yeah, I mean
Mm,
like the code part, everything,
yeah,
build
exactly,
everything.
whatever you see is done. This is all written by developer, and when you create a new project, already some code is written. You call it as a
Yeah,
boilerplate code. Anything that comes with the default creation, right, you call it as a boilerplate code basically. Okay, anything you write is your own code.
yeah.
Okay,
Okay.
and developer is not doing, he simply add the projects, he write the code, and he will go and build it. Okay,
Yeah,
clean solution is nothing but I shown it. Clean is nothing but it will go and delete all the files from the bin folder, because those are temporary, right? You can simply generate by clicking on the build basically. Why people use clean solution? Sometimes what happens, because of your temporary files, or some caching files, you may see some weird behavior from any tool basically. That's the reason we go and delete our temporary internet files as well, right? Many of the times. Okay, the same thing we do using clean solution. When you do clean, it will go and delete all the files from the bin folder, and then you can run it so that there won't be any issues. Okay, you can see here quickly. So let us say microservices, bin folder, right? There are many files here, right? Some of you see .pdb happens from the debug basically. You see many files here. Okay, now if I go and do a, let me do like this. Sorry, now if I go and do clean solution, it is cleaning all the projects in the solution. You see everything is clear, right? That's called clean solution. We always do that as a best practice, so that I don't get any conflicts in terms of temporary files basically. Okay, okay, that's good. On the This is on the developer end, right? Now come to the DevOps engineer mode. Okay, now you need to do it all these things from the Azure pipeline. So what you need to know for building a pipeline? First, you need to have a project. So you need to select your solution file or projects in the repository. Everything is in the repository, right? Azure Repos repository. And then you need to have some agent or agent pools. So agent is nothing but a server or a piece of software in that server where it will which will build your solution. Basically, let us say now I have my laptop, right? In my laptop I have Visual Studio software and I am building solution or compiling the solution. But when you run it from the some Azure pipeline uh, product or some Jenkins product, you need some server to run this or to build compile this application as well. So in our DevOps terminology, you call it as an agent, or if you have more than one agent, you call it as an agent pool. These are nothing but a virtual machine. It can be a virtual machine where this build is happening, or it can be a physical machine. Okay, so let us say I'm using right now Azure Repos, right, or Azure Boards we used. Okay, we are doing everything from the web portal, right, but you don't know, right, where that data is stored. That is getting stored in somewhere else, right? It could be in some storage, or it could be in some virtual machine where you have some C drive, D drive, E drive. Similarly, for your build also there need to be some server where all the required softwares are installed. For your .NET to be compiled, you need a minimum some operating system like your Windows Server 2019, or your Windows 10 or Windows 8, whatever it is, whatever you are using minimum. And then you need to have the Visual Studio installed, you need to have the .NET installed, and you need to have all that analyzers installed, right? Okay, so obviously you need a machine, so that machine is called agent. So you need to you need to configure or select an agent as part of your build pipeline. We talk about what is that agent or agent force. So there are two types of agents. One is Microsoft hosted agent, the other one is self-hosted agent. Microsoft hosted agent means when I'm creating a pipeline, I select option as a Microsoft hosted agent. That means all the infrastructure to compile my application will be set up by the Microsoft internally in the background. Basically, you don't know. Basically, when you select Microsoft hosted agent for compilation, in the backend, Microsoft creates a virtual machine and install all the software required based on the project type, and it will copy your project to that machine in the background without your awareness, and finally it will give you the output. So that's called Microsoft hosted agent. What is self-hosted agent? In some cases, okay, you might be using Azure DevOps, or you might be using Jenkins, you might be using Bamboo, you might be using any tool basically, or AWS DevOps. There might be some regulatory compliance issues, etc., where people say, I don't want to run my software or build my software in the cloud. Okay, then in those cases what happens, you can build your own server in your data center and install the necessary softwares required and connect your server with the build pipeline. So if you are managing that server and managing all the required prerequisites and copying content from repos to the server set up by you, you call it as a self-hosted agent. You are responsible for everything here. Microsoft hosted agent, you are not responsible for anything. You just need to select it, and based on the project type, it will create all the virtual machine in the backend. You cannot log in or you cannot see. Okay, and then it will install all the prerequisites as well. Clear what is a Microsoft hosted agent and what is a self-hosted agent? You will see it tomorrow. What is this? But at a definition level, are you clear? Microsoft hosted agent, self-hosted agent. Okay, I'll move on.
Purna, so with respect to self-hosted agents, do we need to install something else, or is that something which we create using Visual Studio?
No, say it's a agent, right? Visual Studio, you already have it on your laptop. But as part of the build pipeline, you are not going to use your laptop, right? If you are using laptop, it's your own. There will be a centralized server, right? You take a server, okay, and install your .NET framework. Of course, operating system will be there. You install your build utilities or .NET framework, etc. You need to follow the procedure to install each and everything. Mostly people go and use install .NET framework, okay, and then create the folders required and connect it with Jenkins, basically Jenkins or Azure DevOps. I'm going to create a self-hosted agent as part of our classes. Don't worry about it. We'll see there. Okay.
Okay.
So, so the scenario that I'm going to take for self-hosted agent is the Sonar Cube. Sorry, we have the Selenium test cases, right? At that time, we use self-hosted agent so that we cover both. Okay. So whatever is the agent, whether it is a Microsoft hosted agent or self-hosted agent, Azure DevOps supports Windows operating system, Linux, and Mac. Okay. So
Okay.
because if you are using a .NET application, mostly you do it in the Windows, not mostly 100%. Okay, Linux, Linux or Unix for Java, right? Or in some cases they also do it on the Windows as well. Mac is mostly for your Apple related stuff. Okay, and currently if you are using Microsoft .NET Core, right, they will run in on any one of these operating. It will be run on Windows, Linux, and Mac if it is a .NET Core application. For you, it doesn't matter. For you, all you need is a server like an agent, Microsoft hosted agent or self hosted agent. But what I'm trying to say, it will support all the all the operating systems. Okay.
Okay.
And as part of this build pipeline, you do, as I told you, you will select the agent or you set up the agent. Okay. And then you will also do some configurations using utilities like tasks, variables, triggers, build options, build retention policies. So these are the things that you will be doing as part of your build pipeline. A task is one group of activities, variables is one group of activities, triggers is one group, build options one group, build retention policies one group. Under this, you will have many different activities. Okay, but at the high level, this is what you're going to do as part of your build pipeline. What you should know in build pipeline. Okay, so now you're going to see what are the different steps involved in creating a build pipeline. First, we need to have some code. That's the reason your pipeline get connected to code repository, right? And you need to set up the environment. Setting up environment is nothing but where you need to build your application solution, right? It could be your Microsoft hosted agent environment or a self-hosted agent environment. And then dependency management, in I just shown you, developers go and download the libraries from NuGet manager, right? Or NuGet package manager or NuGet manager or NuGet, or you can call it as a public artifact. So you need to do that to depend. So that is nothing but dependency management. Means that you have many dependents basically. It can be external dependency or it can be internal dependency. You need to manage that. And then you need to build a solution or project. Obviously build entire solution or project, right? And whatever the configurations I shown, you are going to do it as part of your pipeline. And then run the unit test cases. If it is a developer, they run the unit test cases from their Visual Studio, but you also need to do the same thing from your build pipeline, but it is automated. And then code coverage is nothing but how many lines of code covered by the unit test. That means when you are having 100 lines of code written for any functionality, all those lines of code should be covered by some unit test case. I'll tell you what is coverage. As part of our code review mechanism, what a reviewer is doing, he's going to each and every line, right? He is reading each and every code line and then giving the feedback, right? Hey, this is not how you should do it. You should not use this kind of statements. You have to use a better naming convention, like that. That is a type of code review, right? The reviewer will do it, isn't it? And he provides the feedback. Okay, that means he is when it is manual, the reviewer is covering all the code lines as part of his review. Similarly, when it is automated, your unit test cases will cover all the code lines basically. That is called coverage. For the code coverage, you need to have the unit test cases because he is nothing but your reviewer. in automation fashion. If it is a normal, your person. If it is automated, your unit test cases. When you have the unit test cases, I can configure the code coverage. That means, hey, I have 1,000 lines of code, but only have a 70% of the code lines are covered by my unit test case. That's called code coverage or code quality gates. So I can put some conditions saying that no, if my unit test case success is less than 90%, then fail the build. So your application doesn't have any issue, but as part of best practices, the unit test cases should success should be 100%. It cannot be even 99%. I can set up such kind of code quality gates in sonar view. Okay, so what happens, though the application is working well, since it is not is following the best practices, your build will be failed, saying that hey, your application is okay, but you are not following the best practices. So those best practices will be configured in the code quality gates basically. Okay, and finally, you do set up the environment, you compile the application, run the unit test cases, and you define code coverage and you define code quality case. And once everything is completed, you will generate the artifacts, nothing but your DLL, etc., DLL or your HTML file, etc. That you call it as a publish artifacts section. And all these things can be done by a classic editor or YAML. We will be using the editor because I will tell all these differences tomorrow. Why people crazy about YAML, where they should use, where they should not use. There are a lot of misconceptions about it. When you go to YouTube, 90% of the times you will get uh, I mean, you will get some information where I mean, you don't know where you should use it basically. So I will clear these things tomorrow. Okay. So I have some, I mean, some text for you to consume it actually. Okay. This I will do it tomorrow. Tomorrow, what we do now, you learned what a manual activity or what are all the manual activity that a developer will do, and Visual Studio do it in the background. Okay. And now what you need to know as a DevOps engineer as part of your day-to-day life. Okay, and tomorrow we'll start with the pipeline and we'll go and do all these different activities, environment, dependency management, unit test cases, coverage, code quality gate, etc., as part of this CI pipeline. Okay, and then we also set up sonar cube, etc. Okay, guys, that's for today, guys.
Okay.
Any doubts?
No, but nothing as of now from my end.
Yeah, yeah, so this is an introductory session because if I directly jump into a pipeline, right, you really do not know what I am doing basically. Of course, you will understand what I am doing, but you really don't know where I am going, why I am doing basically. Now you understand that you need to cover all these areas what we seen just now so far as part of our pipelines or continuous integration. Okay.
Okay,
Yeah. Thank you.
thank you. Bye.
Bye.